Okay, today we're learning polynomial functions, so you can write down your title page, and then we do have one vocabulary word down below, so hit pause and record that. Okay, we have some more. We're talking about leading coefficients and degrees. And the degrees are similar to what we talked about in 6.1. So again, copy down the highlighted information. And then here are some basic graphs of different degrees. So copy those down. And then here is the end behavior. And so you'll want to copy all of this stuff down as well. And I just realized we want to actually go back. I didn't realize there was a bottom section down on this page. You'll want to copy down this end behavior as well. So just this bottom section down here. Add that to your notes. And then there's the last thing for you to copy down. Okay, on this problem, you're going to want to copy down the equation. And we need to state the degree. So we've talked about the degree before. You look at each term and see how many variables are there in each term. So this first term has 3. The second term has 2. And then the last term has just 1 variable. And so the degree is the highest number. So the degree in that case is 3. Okay, then the next thing is the leading coefficient. So you go to the term that had the highest degree, and the leading coefficient is the number in front of it. So in this case, the leading coefficient is 7. That's the number in front of z cubed. Okay, and then if it is not a polynomial in one variable, explain. Well, this is a polynomial in one variable because there's only one variable given. We only have z. There's not an extra variable in, like, say, an x there. There's only one variable in this problem, so we don't need to explain that part. Okay, let's try another one. Okay, looking at this one, which one has the highest degree? Or what is the degree of this polynomial? Which one is the highest number? That would be this one right here, and it has a degree of 6. The leading coefficient is the number in front of it, which is -8. And is this a polynomial in one variable? There's only x's given, so yes, it is a polynomial in one variable. So we don't need to explain it because it only says if it is not a polynomial, explain why. Okay, this one now. State the degree. Let's look at this. That one has 3 variables. This one has 2. And this one has 3. So we do have a tie there. But now if we jump ahead in the question, where it says if it's not a polynomial in one variable, which we find right here, it has a's and b's. It is not, and so therefore we can't actually do all of this stuff. Stating the degree and the leading coefficient isn't helpful to us at all here. So we'll say it is not a polynomial in one variable. Because it has a and b. So since it's used 2 variables, we can't do that stuff. Okay, then this time we have a big function. This function is the volume of the volume of air in the lungs during a 5-second respiratory cycle. And so we need to find the volume after 1.5 seconds. So this is just using a function, plugging in 1.5 for our time every time that we see t. So we just need our calculators and plug this in. Oh, that should be a 3 there. Again, plug in 1.5. So go ahead and take out your calculators. You might want to hit pause here. And then calculate out the answer, which would be 0.4766. And it's volume, and they said that that's liters. Okay, so now let's just do it a little bit more algebraically. And so just a review problem. Find p of 1 for p of x equal to 2x squared minus 4x plus 1. All we're going to do is take this negative 1. P of negative 1 equals negative 1 goes in for all of our x's. Okay, so we're just going to take and calculate this section. So you can go ahead and take out your calculators. You might want to hit pause here. And if you plug that into your calculators, you get p of negative 1 equals 7. Okay, so now keep in mind, this part right here is our label. So the function's value at negative 1 is 7. And so this is our answer. We don't need to divide by negative 1. That's a common mistake that people try to do, is dividing by the negative 1. But that's our label. That's our answer. We're done. Okay, and then we're going to throw some variables that we're substituting in. So find the value of b of 2x minus 1 minus 3 times bx if b of m is that function. Okay, so first of all, what we have to do is we have to substitute this into our b function for m. So I'm going to do 2x minus 1 squared plus 2x minus 1 minus 1. So I just put it into this function. Every time I saw an m, I put this in there. Okay, so that was that first part. Then I'm going to do the rest of it, which is minus 3. Now I have to redo it again, but just putting x in for m. 2x squared plus x minus 1. Again, this last part in parentheses, just put it into this part up there. And now I have to simplify this. Okay, so this is where our algebra skills are going to come into play here. This piece right here, I'm going to have to write that out as 2 parentheses 2x minus 1, 2x minus 1. And I'm going to kind of just work this one down first. And so I will FOIL, but I'll keep that 2 in front. First 2 is 4x squared, outside is minus 2x, inside minus 2x. Last 2 is plus 2. And I'll combine these two terms together to 4x squared minus 4x plus 2. And then I'm going to distribute the 2 in. So I've got 8x squared minus 8x plus 4. Okay, keep in mind I only did this first chunk up here. Now I need to go and do the rest. All right, I'm going to continue to write this out. So I need to go plus, nothing to distribute in there, so 2x minus 1 minus 1, and now I can distribute that 3 in, negative 3. Negative 6x squared minus 3x plus 3. And now I can combine like terms, so my x squareds. I've got an 8x squared and a minus 6x squared to make 2x squared. I've got an 8x, a 2x, minus 3. And I believe that's a negative 8. Negative 8 plus 2, negative 6, minus 3, negative 9x. Okay, then I've got the 4, these 1s, and then this 3. So 4 minus 1 is negative, or is 3, minus 1 is 2. 2 plus 3 is 5. So that is the value of our function. Okay, let's go on and talk a little bit more about graphs now. So we've got this graph here. We need to describe its end behavior, determine whether it's odd or even, and then state the number of real zeros. Okay, one of the hardest parts of this one is recognizing what end behavior is. So what we need to talk about is as we go to the right, so if I'm drawing this graph to the right, what's happening to the function's value? Is it increasing or decreasing? So we would say it as x goes towards positive infinity. So as we get bigger over on our x-axis, so we draw our graph to the right, our graph is going to go down into negative infinity. So we'll say f of x, which is our function, is going to go to negative infinity. Okay, so we talked about what happens if we go to the right. Well, what happens if we go to the left? As we go to the left here, if we were to draw our graph, which way is our graph going to go? It's going to go down again. So we say as x goes to negative infinity, because to the left, we're going to negative infinity, our function, f of x, is going to go, what's going to happen to it? It's continuing to go down further and further, so it goes to negative infinity again. And then we have to decide, is it odd or even? Okay, we'll go back and we look at our tables that we wrote up above. Let me find it here. Okay, so notice here, odd, they're going in opposite directions. Evens, they're both going down. Odd number, they're going opposite directions. Even, they're going the same way. Odd number, they're going in opposite directions. So the fact that ours are both going down, let's go back to the problem here. I'm trying to find it right there. Okay, so the fact that both of ours are going the same way, they're both going down, that has to tell us that it is an even function. If they're going opposite directions, then it's odd. And then the number of real zeros. Well, we wrote that down also. Real zeros is how many times it touches the x-axis, or intercepts the x-axis. And this never does, so it has no real zeros. Okay, let's look at another one. End behavior again. So as our x value gets bigger, we go to the right. If we were drawing this graph to the right, which way is the graph going? So as, oops, I should start with as x, can't write that out. As x goes to positive infinity. So as we go to the right, because that's towards positive infinity, what happens to our function? F of x is going, well, f of x, remember, was going up as we go to the right, and so it goes to positive infinity. Okay, let's go the other direction then. If we go to the left, so as x goes towards negative infinity, f of x, our function's value, what's happening here? It goes up a little bit, but then at the end, it goes down a long ways. So it's going to go to negative infinity. Okay, so if they're going in opposite directions, is it going to be an odd or an even function? Okay, odd or even. Opposite directions, that means it's going to be an odd function. Or odd degree function, we could say that as. And how many real zeros does it have? How many times does it cross the x-axis? Just once. So one real zero. All right, and that is the entire lesson, so you can write your questions and your summaries.